Hello! This video is going to focus on 3 by 1 digit numbers and using partial products and the standard algorithm to solve these kinds of problems. So in the last video I went over area model and partial products and how those were pretty similar and connected. But just like that, partial products and standard algorithm are also pretty connected. So I'm going to show you a different way to lay out the partial products that looks really similar to using the standard algorithm, and then we'll practice some problems using just the standard algorithm as well. Okay, if I wanted to start by multiplying, let's go 214 times 6. And I wanted to use partial products. So we're just using the numbers here. Last time I showed you how to split this up. So we looked at this like 200 plus 10 plus 4 multiplied by 6. But I'm going to set it up so it looks really similar to the standard algorithm. What I mean by that is I'm going to set it up like this, but I'm still going to go through each of the parts and show you what that looks like. So if we started in the ones place and I multiplied 4 times 6, I know that 4 times 6 is 24. So I can just write my answer there. My next step will be to multiply the 1 by the tens. So if I look at that as 10 times 6, I know that 10 times 6 is 60. So I could put that right below here. And then last but not least, I need to multiply the ones by the hundreds place. So that would be 200 times 6. And I know that 200 times 6 looks like 2 times 6, which is 12. But because it's in the hundreds place, I need to add 2 zeros. So those are my parts. And like I said, I'm going to go back and show you how this looks like the last video that I did. So I first started by multiplying 4 times 6. That was in the ones place. Next, I moved over to the tens place. So that became 10 times 6. And then last but not least, I moved over to the hundreds place and multiplied 200 times 6. And it's really important that we understand the place values and how each of these partial products fit in with one another. So I'll show this again using a different problem, but I wanted to lay it out in a different way because this will look really similar to the standard algorithm, and that is what we are going to be moving toward as you are entering 5th grade. Okay, so I need to add up each of these parts, and just so I don't confuse myself, I'm going to just erase that so I can focus on the answers. But if you need to go back and rewatch that part of the video, that's how I got these numbers. Okay, looking in the ones place, of course, 4 plus 0 is still 4. 2 plus 6 is 8, plus nothing is still 8. Nothing plus 2 is still 2. Nothing plus 1 is still 1. So using just the partial products, remember that's each of these pieces here, I found out that 214 times 6 equals 1,284. Again, I will show that again using a different problem, and then we are going to go into the standard algorithm. Erase that. Okay, let's look at 308 times 4. I'm going to set this up like this. And then look at each part using the partial products. So I always start in the ones place. So I'm going to solve 8 times 4 first. I know 8 times 4 is 32. Next, I need to go to the tens place. And there's actually nothing in the tens place. So if I multiplied 0 times 4, I would get 0. Anything multiplied by 0 stays 0. So I actually don't have to write anything there. I don't have to write a 0 to hold my place or anything like that. I just know that there's nothing going to be from the tens place. And then lastly, I need to multiply by the hundreds place. So I need to look at this as 300 times 4. I know that 3 times 4 is 12, but because it's in the hundreds place, I need to add 2 zeros. Like that. And I'll go back and show you where these numbers came from. I started in the ones place and multiplied 8 times 4. And then when I moved to the tens place, the blue here, there's nothing to be multiplied. 0 times anything stays 0, so that's why there's no number written in blue. And then lastly, I moved to the hundreds place and multiplied 300 times 4. So those are my partial products. I have 8 times 4 and I have 300 times 4, and now I need to add those together. Again, just so I don't confuse myself, I'm just going to erase this, but you can always go back and look to see where those numbers came from. Okay, 2 plus 0 is still 2. 3 plus 0 is still 3. Nothing plus 2 is 2. Nothing plus 1 is 1. So I know 308 times 4 equals 1,232. So that was partial products. It looked a little different than the last video because I am setting you up to work toward doing the standard algorithm, but you are doing the same exact thing. All I had to do was take each of the parts of 308 and multiply it by 4. So I took the ones place, 8 times 4 gave me 32. Nothing multiplied by the tens place, and then moved to the hundreds place, which was 300 times 4, and that gave me 1,200. Next, I'm going to show you what the standard algorithm looks like and how it's really connected to partial products. I'm going to erase these. Right, if I had 428 times 3, and I wanted to multiply this using the standard algorithm, I would first set it up vertically like this. I'm trying to make it bigger so I can show you each of the parts that I'll be doing. Just like everywhere else, we have started in the ones place, so we are going to continue doing that. Again, I'm going to rewrite this so I can write it a little bit bigger. Okay, 428 times 3. I'm going to start in the ones place and multiply 3 times 8. I know that 3 times 8 is 24. The 4 stays in the ones place, and the 2, or the 20, goes right above into the tens place. So again, I just multiplied 3 times 8. I know that that is equal to 24. If you want to keep track, you could write your answers on the side here. The 4 will stay in the ones place, and then the 20 gets carried over to the tens place. Next, I need to multiply 3 times 20. Again, you could think of that as 3 times 2, because in the standard algorithm, that just makes it easier to deal with. I know that 3 times 2 is 6, but I cannot forget the 20 that I added over here. So 6 plus 2 is 8. I know that this answer isn't actually 8, it's 80, because it's in the tens place. So if I had 3 times 20, I know that that is 60, because 3 times 2 is 6, plus 1 0 since it's in the tens place. But I have to add the 20 from before, and that's where I get the 80, or the 8. So again, when you're doing the standard algorithm, you can think of this as just 3 times 2, which is 6, plus 2 more, which is 8. Over here, I'm showing you what that looks like using the place values. But if it's easier for you to think about just using the single digits, go for it. All right, last I need to multiply 3 times the hundreds place. Again, I'm going to think of this as 3 times 4, and I know that to be 12. Again, that's not just 12, it's actually 1,200. And I know because 3 times 4 is 12, but because the 4 is in the hundreds place, I have to add 2 zeros to my answer. So I think it's helpful to see my math on the side because it really connects to the partial products. I first did the ones place, which was 24. Then I moved to the tens place, which I know is 80, because 3 times 2 is 6, plus 2 more is 8. And then lastly, I went to the hundreds place, 3 times 4, which is 1,200. And you're done. That's it. This is the quickest, most efficient way. So eventually we want to get to this method of solving problems like this. But if you're not there yet, that's okay. You can use any of these strategies and that would be totally fine. I'm going to take the time to do one more problem using the standard algorithm. I'm going to erase this. So if I wanted to solve, let's go 605 times 7. And I wanted to use the standard algorithm to solve this problem. I would rewrite it. Vertically like this. Again, I tried to write it big so I could show you the steps and what that looks like. Starting in the ones place, I need to multiply 7 times 5. I know that 7 times 5 is 35. The 5 stays in the ones place, and the 30 goes to the tens place. Next, I need to multiply 7 times the tens place. So since there's nothing in the tens place, I need to still multiply 7 times 0, which is 0. So that eliminates the 7. Anything times 0 stays 0. But I still need to add the 3 in the tens place that I carried over. So 7 times 0, I have to do that step first, is 0, plus 3 more is 3. This is one of the more common errors that I see, is that if there's nothing in the tens place, then they will just multiply the 1 by whatever was brought up here. But if you treat that like it's not there, you have to do this step first. You have to multiply the 1 by the tens. If there's nothing there, then your answer is 0. If there's something to add, then you can add that at the end. But this step must be done first. Okay, last but not least, we need to multiply the ones by the hundreds place. So 7 times 6 I know is 42. So I can just write 42 right here. Again, I know that's not just 42, that's 4,200, because 6 times 7 is 42, but because it's in the hundreds place, I have to add the 2 zeros. If this step over here is confusing, you do not have to keep track of your partial products on the side. I'm just trying to show the connection between that strategy and the standard algorithm. When you're multiplying using the standard algorithm, you can treat these numbers like single digits. 7 times 5 is 35. 7 times 0 is nothing, plus 3 more is still 3. 7 times 6 is 42. As long as you are making sure that you put your answers in the proper place value, it is totally fine to think of this that way. You just need to know that the place values matter. We're multiplying in the ones place. If there's nothing in the tens place, then there's nothing to add. And then multiplying in the hundreds place actually looks like this. So as long as that makes sense to you, you can think of this strategy however you'd like. We just need to make sure that we are making the connection between the place values, because that's really important and that will help us moving forward. Okay, the next video I'm going to do the same thing, starting with partial products and then going to the standard algorithm, but for 4 by 1 digit. Look for the assignment on Canvas. It will be similar to the Monday assignment where it's like a quiz form. So take a look at that and see you for the next video.